Hello students, in this short video, we are going to discuss the result that join and meet are commutative operations in a lattice. Now we already know about the operation join, which is denoted by V, and the operation meet, which is denoted by inverted V, and what is the lattice, that we already know. This has been discussed in my earlier videos. So we just have to show that join and meet, which are two operations where join of two elements is defined as the supremum of two elements in a lattice, and the meet of two elements in a lattice is defined as the infimum of the two elements in the lattice. And in the lattice L, we can always talk of supremum and infimum of a pair of elements. So join and meet are valid operations or well-defined operations in a lattice L. So we just have to show that these two operations join and meet are commutative operations, which means that there are two parts actually to this result. The first part is that we have to show that join is a commutative operation, which means that if L is a lattice, let L be a lattice. We are working in a lattice. Let L be a lattice. Then we have to show. Then we have to show there are two things we have to show in this particular result. Then we have to show that A join B is same as B join A, which means that join is a commutative operation where A and B are elements of L. And the second part to this result is that A meet B is equal to B meet A, which means that meet is a commutative operation in the lattice L. So let me prove the first part. That is, we have to show that join is a commutative operation. So now A join B, if you take by definition, as I said, the join of two elements A and B, where A and B are elements of the lattice L, the given lattice L, the join of elements A and B is defined as the supremum of the elements A and B, or this is the least upper bound of the elements A and B. Now, when you write that this is the least upper bound of A and B, this is equivalent to writing least upper bound of B and A. You can change the order of the elements, or you can write the supremum of B and A. It's one and the same. And the supremum of B and A is nothing but B join A. So therefore, A join B comes out to be B join A, which means that join. This implies that join is a commutative operation. Join is a commutative operation. Join is a commutative operation in L. So this is one thing. And the second part to this result is that we have to show that A meet B is equal to B meet A. Now this particular result actually follows from the first one only. Since we have proved that A join B is equal to B join A, since we have already shown that A join B is equal to B join A, that is join is a commutative operation, then by principle of duality, the dual of this statement, which is already true, is also true, because we know that the duality principle holds in a PO set. And by duality principle, every statement which is true in all the PO sets, the dual of it is also true in all the PO sets. Now, since we are working in a lattice, and a lattice is a PO set, it's a special type of PO set, but we can regard lattice as a PO set. Then, although it's a special type of PO set in which join and meet are defined, but in any case, the duality principle holds in the lattice cell, and since this statement is true in lattice cell, therefore the dual of this is true. And how do you obtain the dual of the statement? By changing every occurrence of join with meet. Wherever join occurs, change it to meet. So changing join to meet, we get this result, which shows that meet is a commutative operation in L. So by using duality principle and by using part 1, this result follows. But you can immediately, otherwise also you can immediately infer that meet is a commutative operation, because if you consider A meet B, then A meet B is infimum of A and B by definition, and infimum of A and B is the greatest lower bound of A and B. And rather than writing it as greatest lower bound of A and B, we can write it as greatest lower bound of B and A. You can change the order of the elements, and greatest lower bound of B and A is actually, you can write it as infimum of B and A, or this is B meet A. In the notation of meet, this is B meet A. So A meet B is proved to be equal to B meet A, which means that meet is a commutative operation. So independently also part 2 can be shown like this, or you can show part 1 first and then you can use the duality principle. So that is all about the result that join and meet are commutative operations in a lattice.